Okay, so this is the briefing video for the crystal field theory experiment. So the purpose of this experiment is to give you practice of making a metal complex like this sort of copper complex shown here with ligands sort of surrounding the complex, and to also then use UV vis absorption to analyze these types of complexes, because UV vis is the main way in which we can sort of determine what type of ligands we have surrounding a metal. So the synthesis of the complex is quite straightforward. So it's a short experiment where you sort of heat and stir the reagents together to make your sort of copper iodide complex, and then you filter and recrystallize your sample in water, and this should give you sort of purple crystals for this particular product, then your sort of analysis that you'll do is with IR, which will help show sort of the absorption of the NH bonds and the OH bonds there in your complex to show how it's sort of complex to the metal. So this is a short experiment. It should only take about half a day to do. Following the experiment, this is where you're going to do some UV vis analysis. So this will be in your own time after the experiment, and this is where you'll sort of see and understand how UV vis can actually be used to sort of analyze what type of metal complexes you have. So in this particular experiment, you'll have data of these various different copper complexes, and you'll be able to see with UV vis data how the absorption data is different for these different complexes, and be able to see how by increasing the number of ligands that are attached to the metal and displaces water, how it changes the UV absorption data. And this UV absorption data is sort of linked to the electronic transition of the sort of unpaired sort of d electrons of copper, so a D to D transition, and that's related to the absorption that we see through the Beer-Lambert law, which you've sort of learned elsewhere in your course. Okay, so what you have on Minerva will be some the data for each of those three sort of complexes, and the post-lab questions will guide you through how to use this data. So what you'll be doing is you'll be sort of plotting the data like so to get your UV absorption. Okay, so across various different wavelengths, you'll see where you'll have your lambda max for where you get the maximum UV absorption for each of the copper complexes, and from that you'll be able to calculate the lambda max values that you have, and therefore be able to see how it changes for the different complexes, and you'll be able to plot the spectrochemical series to show how the ligands sort of change and affect those sort of D to D transitions, and in effect show how strongly the sort of ligands sort of bind to the copper complexes to sort of affect that UV absorption data. Okay, so just to reiterate, the questions in the post-lab analysis will guide you through what you actually have to do in terms of analysing these types of copper complexes through the UV absorption data. And make sure you include the plotting of the data and your sort of analysis of this data in sort of into your lab book as part of your lab book, your post labs for the experiment as well. Okay, so that's the summary of what you're doing for the crystal field theory experiment, and kind of how the synthesis and the UV data sort of link together to help you understand and analyze how we sort of analyze these types of sort of copper complexes.